Welcome. In this video, we're going to take a look at the central difference method, which is a mathematical way of calculating velocity if you have displacement data from something like video analysis. Before we get started, you should have probably reviewed the video that looks at the relationship between velocity and the slope of a displacement curve, and you should have probably reviewed the video analysis video. So for this example of the central difference method, we're going to take a look once again at this bench press video that we looked at in the video analysis video. So in this one, we were interested in the upward movement of the bar during the bench press. And we can calculate that. So let's say we've done the analysis, and this is a graph of the vertical displacement over time from that video analysis. So each one of those circles is vertical displacement data from an individual frame. And so we have the displacement data. Now what we'd like to do is calculate the velocity of the bar during the bench press. And so our average velocity formula, if we remember, is the change in displacement over the change in time, just like that formula there. And so we could take any two frames and find the velocity between those two frames. So the initial would be that first frame and the final would be the second frame, and essentially what we're finding is the slope between those two frames. So that would be the velocity. And this is fine, but what this actually gives us is the velocity, the average velocity between those two frames. So it's the average over that delta t. And normally, although that's useful information, normally what we'd like to get is the velocity right at a given frame. And taking it between these 2 points doesn't give us that. So we have to have a slightly different approach. So this is a representation of the same kind of data we saw in the previous slide. So we've got a displacement data over time. And so each one of those circles is data from a frame. And we're interested in those three middle frames. So those three displacements. And if you notice, the displacements have subscripts with the letter I. And that's a mathematical convention which allows us to kind of generalize frame numbers. So in other words, that the subscript I actually represents the current frame number. And then the subscript I plus 1 represents the frame after, or the next frame. And the subscript I minus 1 represents the previous frame. So we can use those subscripts to develop a generalized formula that we can just plug in a number where the I is later on when we want to do the analysis. And so we've also got on that representation, we have the delta t, which is in other words the time between those frames. So we've got those three frames highlighted in yellow and the delta t between each one of those frames. So what we'd like to do, what we're really interested in, is finding the velocity at the frame I. So in other words, finding the instantaneous slope at that point. And that's where the central difference method comes in. And the idea behind the central difference method is that you can approximate that instantaneous slope or instantaneous velocity at point I by taking the slope between the point before it and the point afterwards. In other words, the slope of that solid blue line. So in other words, if we want to find the velocity at point I, we want to find the slope of that solid blue line. So in other words, it's the rise, which is the difference between the di plus 1 and di minus 1. So final minus initial. And then we divide by the run, which in this case is across those two frames. So in other words, there's two delta t's involved in that run. So the run is 2 times delta t. And so this is the central difference method formula for calculating the velocity at a given frame. So the velocity at a given frame is the difference between the displacement at the frame before it and the frame after it, divided by 2 times the delta t, or the 2 times the time between frames. So let's look at an example of this, a numerical example. So we'll go back to the bench press video, and the first thing that we need for that central difference method formula is the time between frames. So if we remember from the video analysis video, that the time between individual frames is just 1 over the frame rate. So in this case, the bench press video was taken at 30 frames per second, so the delta t is 1 over the 30 frames per second, or the delta t is 0.033 seconds between every frame. So now we have the delta t. We can figure out the rest of the formula. So what I've got here is a subset of that vertical displacement data. So we've got data from frames 4 to frame 8 of that video. And you can see there's the vertical displacement for all those frames. And we're interested in trying to find the velocity at frame number 6. So in this setup, frame number 6 will be frame I. And so frame number 7 is frame I plus 1. And frame number 5 is frame I minus 1. So we know our delta t already from the previous slide. And so we just need the two displacements now. So the displacement I plus 1, or displacement for frame 7, is 0.062 meters. And the displacement at frame I minus 1, or the displacement at frame 5, is 0.032 meters. And so the velocity at frame I, or frame 6, will be the change in displacement, in other words, the 0.062 minus 0.032 meters, divided by 2 times delta t. So if you do the math, you end up with the velocity at frame number 6 is 0.455 meters per second. So normally we would do this for all the frames, so we would get the velocity profile across every single frame.